So, our first question is about integrating methods, and the way we will set up the panel is that the panelists first present their view for 5 minutes each, and then we have a short Q&A session of 10 minutes so that we can go on with the second panel and have the same exercise. And in this way, hopefully those who can stay only for an hour, at least they got the most of it, but then we will have some extra time for general discussion. And I gave a total freedom to the panelists to pick their topics. I just gave them some ideas of what they may want to reflect upon, but of course it was merely an indication and in no way constraining their views. So I'm really curious to hear about their views on integration. Maybe something I can say is that at the moment in philosophy of science, integration is a matter of hot debate, trying really to understand what that means from the practice perspective, but also from more a theoretical perspective, and showing examples when this has happened, of where it should happen. So it is a rich field, and I'm really interested in seeing how this strikes people who are kind of in the field, actually working with different methods and confronting with this on a daily basis. Maybe it will be kind of a very interesting lesson for the philosophical community as well. Okay, so in the order of my screen, I see Lasse and then René. Lasse, would you like to start with your statement about what is integration, or whatever you want to talk about it?
Yes, yes. Thank you so much, Federica. Thank you for the invitation, and I'm so happy that at the beginning you said that we do not necessarily need to consider ourselves experts, because that takes away some burden of this little introduction. So I've spent some time meditating on that question that you, or the questions that you posed, and I'm in the field, so that is where I'm. I have to work with methods and I have to try to come up with answers. That's where I'm coming from. And what I observe in practice is that most of the scholars, people that I read or that I observe working, deploy one method with its associated epistemology and ontology. And as such, there's very little in terms of integration. Some scholars use mixed method designs, and that seems to be currently a bit of a holy grail in the social science. You can see a lot of people calling for that, and I can see why. You can do that sequentially, or you can do it in parallel. There are several combinations possible, really. So the thing is with mixed methods is that it's still like Legos. It's like, you've got the bricks and you can recombine them in any kind of way. So I've got a little car here, a little Lego car, and I can add a few more bricks and it becomes a little steam engine across the mountains or whatever it is. But it's still discrete bricks. They are not necessarily merging. I'm just making a bricolage and assemblage of different methods that I somehow connect one way or the other, but there's no integration as such. We just use them sequentially or in parallel or whatever. Why do they remain discrete bricks, if you don't mind me using that metaphor? Well, first of all, because the epistemology and the ontology that are underneath these bricks are so different that an integration is just simply too much to ask for. So, for example, if I use set theoretic methods, which I do most of the time, with a regression analysis, I would need to merge two very different understandings of causality. Conditions instead of variables, conjunctions and disjunctions instead of covariations, and so on. And that's not mere semantics. It's not about replacing one term with the other. It is really about a very different way of thinking about how something, I don't know, an institution, a behavior, a thought, agency, a group of people, whatever, come into being, sustain, disappear, etc., etc. Fundamentally different. And so that means that integration is really very far away. So getting back to Federica's earlier point, so is integration possible at all? Well, I would say we're not there yet. I do see people becoming increasingly aware of those differences, and to me that already is a great improvement. But I do see fundamental obstacles in integrating things. That is by the way, not a problem as far as I'm concerned. When it comes to the social science, at least, and complexity science in particular, when it concerns the study of social complexity, I think we're all in the same basement. We're looking in different corners, using different types of flashlights, and altogether we can create a more coherent picture. It does not create a bigger flashlight. It does not illuminate every nook and cranny of that basement, but we are able to create a better picture than, let's say, 50 years ago. Where to next then? Well, I do believe that perhaps contrary to what lots of publications have been saying, is that more computational power or more advanced statistical modeling will not pull us out of this place. I do think that there's a need for more human creativity to rethink the ways in which we deploy our methods, our models. And in doing that, again, coming from the field, I advocate for a certain pragmatism. What works is what is important. And in getting there, in understanding what works and what does not, and the conditions under which something works, I believe we should become much, much better at abduction. So for me, that is the key word here towards putting insights together, is abduction. That's not necessarily integration, but I do think that it would provide us a stepping stone, perhaps towards getting there, but at the very least, towards understanding better what works and what does not. So those were some initial thoughts from my side. Thanks, Federica, gave me an opportunity to harvest the Legos of my son. I'll be happy to return the floor to you.
Okay, thanks so much, Lasse, also for keeping the time. So, in the meantime, welcome, Joris. So I pinned you because you're in the first panel. So maybe I ask René to go next for his 5 minutes.
Yes.
René, please, the floor is yours.
Thank you. I must say that perhaps some of my thoughts resonate definitely with what I heard from Lasse. So first off, I definitely also don't consider myself an expert, but rather, let's say, somebody applying methods from a certain field, and also, let's say, increasingly feeling at unease or perhaps conscious of, let's say, the limitations of the methods that you apply. So that is what raised my interest in this subject. But if you take that question of what does it mean to integrate different methods for causality, then my first question would be, what do we mean when we speak about integration in the first place? What do we mean with the term integration? But another question that it raised for me was, can we, of course, is this about can we integrate, or is it about should we, do we want to integrate? And if we then want to integrate, are we then integrating towards one single framework, or is it more integrating of multiple frameworks? My take on this for now would be that I think we should strive to integrate, because I think there's a lot of richness in let's say having multiple lenses, looking to multiple lenses to the same topic. It's a bit like, let's say, the richness of multiple people looking at blind people touching the elephant, right? As long as they know that they're doing this together, then perhaps their shared image is still a relevant one. So my stake would be that I think we need multiple methods to prove causality or not, and that it in fact may even have negative effects if one method starts dominating the field too much. And that is something that I feel that may have happened in the field of evidence-based medicine. And the classical illustration of that was a paper that was written from the field of geriatrics, so that's my own field, and that's a fictional case of an older woman with multiple chronic conditions, and what would happen if this woman would be treated for each of these conditions strictly according to the clinical guidelines that have been developed for single conditions, using RCT evidence. So we know, I mean, we take the best evidence for each of these single conditions, and we apply all those interventions to a single individual who has all these different conditions. You would say that's good care. it turns out that that this results actually in a lot of undesirable effects with first of all, a very complicated treatment regimen, but also potentially harmful treatment interactions. And it is evidence-based medicine that has brought us there for a very large group of people. And actually, it has even been further enforced by the fact that because of the dominance of evidence-based medicine, this has also led to pay-for-performance schemes that pay professionals if they follow the guidelines. So that increase, that let's say results in incentivizing wrong behavior. I think that of course, I mean, I'm a very profound proponent of evidence-based medicine, but we should be careful how to apply it. Because of course, in theory, what you could say, well, but we can evaluate treatment using RCT evidence also for persons with multiple chronic conditions. But the number of combinations that are possible, they are so large that this will in practice be impossible. And also there's a good reason why we don't have that evidence for this 84-year-old lady with multiple conditions, because we consider it not ethical to do a randomized controlled trial in this patient group. And the same goes for risk factors. We consider it not ethical to randomize people for smoking behavior, for example. I mean, you can randomize smoking. It's nobody who will do it, but you could, in theory, do it. So we need multiple perspectives on this. And another example that I also, again, take from the same field of evidence-based medicine is because the RCT has been so successful in our field, we also now increasingly are interested in applying this to complex, multifaceted interventions that we increasingly are interested in. So this could be the introduction of shared decision making. This is a very hot topic in the field, and of course everybody understands that this depends on having the right training materials available. This is about the behaviors of the professionals, about the behavior. So this is very complex already, and we tend to evaluate these in RCT frameworks as well. And the evidence is always contradictory. Sometimes it works, sometimes it doesn't. And this is because it ignores, I think, the local context and the sensitivity to initial conditions that play a role in this evidence. So the evidence that we generate doesn't generalize to other situations. And rather than asking, does this work, we should ask, why does it work? Which elements work for whom and under which circumstances? And for that, I think we need evidence from multiple sources. So we need indeed those mixed methods. So, and I leave it here. So my message would be that we would want to strive for integration, but if see this wealth of methods as a richness, and of course, I mean, if we can integrate, we should definitely do it. But it's valuable. As long as we know this and don't have one of the fields dominating too much the other approaches.
Okay, thank you so much, René. So, Joris, if you want, you can start with your 5 minutes. Thanks for making it.
Yes, thank you. I think René has made my job a little bit easier by giving a nice introduction, let's say, to what I would like to talk about today. So first of all, the question, what does it mean to integrate different methods? I don't have a direct answer to that, perhaps, but I can say that if you want to integrate different methods, then you probably should first make sure that that these methods are using a common language, so that they are expressed in the same language, let's say. So you would have to find a framework that, let's say, a mathematical framework, for example, that allows you to formulate these different methods and then to integrate them. Just like if you want to add a length in meters to length in inches, then you first have to find a kind of a common unit, so to speak. So that is something that is a first step, I think, before you can integrate methods or results from different methods. And if you then want to do so, well, then there are many methods that you could integrate, of course. So there's quite some work, I think, in working out the details of how to do this. So I'm not sure if you placed me in this panel because my latest work is actually on integrating interventional and observational data for estimating causal effects. So that's either a nice coincidence or it was on purpose, perhaps. But we have, so as René already explained, in evidence-based medicine, it's based on randomized controlled trials, and they have all kinds of disadvantages. But on the other hand, we also have more and more observational data, let's say in medical settings. For example, electronic patient records where patients are observed, treatments are logged, and the outcomes are measured and logged. So then there's this wealth of data, this observational data. And it would be great if you can somehow deduce some causal insights from that observational data, for example, to estimate the effect of a certain treatment or the dosage of a treatment on some outcome, and perhaps combine it even with randomized controlled trial data. And that's actually exactly what we very recently proposed a method for doing so. So our first step was indeed, if you have this mathematical framework for causal discovery from observational data and for interventional data, first step was to combine them in a unified framework, and then to basically to exploit that there's some interaction between the distributions of the data that you can see in the observational setting and in the interventional setting. So they are not completely independent. So there's, in the observational data, there's some information about the interventional data. And if you, if you use the right approach, then you can actually combine the two types of data. And thereby we have only shown it on simulations so far, but we could, for example, reduce the number of participants in a randomized controlled trial by a factor of 2 to get the same accuracy of the estimated causal effect by adding plenty of observational data. So yeah, we are quite excited about this because this is a new, really a new method. And the nice thing is you don't need to assume that there is no latent confounding in the observational data, which is well, a major weakness, I would say, of other methods that use observational data for estimating causal effects in a medical setting. So yes, I think we should try to integrate different methods, and it actually yields interesting research questions on how can we do this in practice.
Okay, thank you so much, Joris. So we are keeping the time, which is great. So I would like now to open the floor for a quick round of Q&A to our panelists. And then we will also have more time later for general discussion. I don't think I can see everyone on my screen, but I have the list of participants. So if you raise your virtual hand or your electronic hand, that would be easier for me to keep track of who wants to speak. So anybody wants to ask a question for now? Because otherwise I would have some elements to begin with. I don't see any hands yet, so let me get this started.
Sorry, Federica.
Lasse, yes, go ahead.
I forgot to press I probably pressed the wrong button. I would have a quick question for Joris. How would you, in your view, then deal with those data that are, let's say, that escape formalizing or escape even quantification, so that you could use the mathematical model? So how would you deal with things like experience, for example, which is often expressed qualitatively, but still something that worth researching in your view of integration, which really hinges on formalizing things and expressing them in mathematical models, how would you account for those things that escape that kind of formalization?
That's a good question. I think so as a mathematician, or let's say a data scientist or so, I would typically only work with those aspects of the world that can be formalized. I wouldn't know what to do with other aspects.
Okay, I see. Yeah, thank you.
Sorry.
Okay, I don't see other hands, so let me try to, because what I find interesting in the three contributions here is that you seem to have very different things in mind when it comes to integration. So Joris went straight to the problem of data integration, which may be a very specific way of understanding integration. Lasse, instead, in my mind, was trying to talk about of integration at the level of methods and of the epistemologies that go with these methods. And of course, the two types of integration may be connected somehow, because if we analyze certain types of data with certain types of methods, then at some point Lasse and Joris' problems have to be connected in some way. But it is interesting that you pose the question in kind of distinctively from different perspectives. And then what I heard from René is it is as if the question posed by René is we have this multiplicity of methods out there, and we observe episodes of that I like to call imperialism, like the EBM framework that tries to do that. But maybe for me the question to René would be, do you see the evidence-based framework as an attempt to not just integrate but collapse everything into the same basket, you see? So I guess your contribution is interesting to reflect on these dimensions, the plurality of methods, some of the attempts to establish one method over the others, and whether this implies integration or whether it is something different. And to me, these are all genuine questions, really. I don't know whether any of you wants to react, maybe René.
Well, I don't know if there's, let's say, a conscious effort to put everything into the same basket, but it's perhaps what is happening is that we see that because we see that evidence, so the RCT is a very successful approach to understanding causality for some problems, we will start evaluating everything according to that ruler. And also and you see this, so for more complex interventions like these multifaceted interventions, I think it's much more difficult to get that same type of evidence than you get for single interventions focused at single persons in fairly uniform groups. And thus, and for example, healthcare insurers have much more difficulty, let's say, financing those more complex interventions because of the fact that it's much more difficult to show, let's say, how they are relevant. Yeah. So I think it's not. If you go back to let's say the original underpinnings of evidence-based medicine, one of the it was more meant to be a device for a clinician actually than for, let's say, healthcare as totality. So clinicians were sort of motivated to use the best possible evidence, but deviate from that evidence if they found that this would be better for their patient. And this latter bit is still in there, and but it's sort of a bit, let's say, it's not so prominent anymore because of let's say the other developments in evidence-based medicine.
Yeah. I think I totally share your concerns, René. I guess I would like to press you a bit on this, not because I disagree, but because it may be useful to the discussion. Meanwhile, Joris had to go. I mean, what would be the difference between having an integration and a domination of methods. You see, I think the way I make sense of what you are saying, and as I said, I agree, is really the attempt of one approach to dominate over the others is wrong for a number of reasons, and you gave multiple examples for why this is wrong. But as I see it, this seems to me quite different from the example that Lasse was trying to give about mixed methods research, in which you can say, I have one phenomenon and I'm using method A, B, and C in different orders, depending on how I want to frame it, depending on the data I have, blah, blah, blah. And I'm not sure whether this is really integration, because the methods are really kind of still very discrete, but still they want to converge towards explaining problem A, you see. So I'm wondering, there must be something about how the two things are connected somehow, and maybe we can continue this in the general discussion later on. You put the finger on a very important problem, I think, and I'm glad that you did that, because the idea of the gold standard in methodology is pervasive, and so we may want to have a good argument for why we don't want it, this gold standard. But if we get rid of the gold standard, then what? Okay.
Yeah, I agree. So I think indeed, let's say the approach of mixed methods is a more healthy one. So this is also the point that I wanted to convey, is that I think that of field and our understanding of the problems that we are facing becomes much more rich if we allow other methods into using them.
Yeah. Okay, thanks so much. I think we had a very great start for this first panel. So let me keep an eye on the clock. So maybe this is a good moment to unpin Lasse and René, and then to pin the other ones. So my list. So now I should pin Esther, add pin, and then Sonia, and then I should pin Kiss. Okay, there you are. Okay, so our second question today is where is the researcher? Okay, where is the researcher with respect to the object of study, with respect to the method, with respect to the world? I don't know, up to you to tell us. And maybe before I give to the floor to the three of you, maybe just a clarification. I don't have a clear recollection of how we came up with the final list of panelists. I think I made the first proposal, and then there has been a back and forth between me, Joyce, and Peter. So don't ask me exactly why you were chosen, but you were chosen, supposedly because you would have something interesting and useful to say about these questions. Just as before, I gave some possible hints about how to think about the role of the researchers to Esther, Sonia, and Kes, but again, with no obligation to stick to the questions I asked or to or my framing. So again, a total freedom to the three of you to share your thoughts. And as I see you in the order on my screen, I see Esther first. Esther, would you like to start?
Yes, sure. So you asked, can fields abstract from the role of the researcher? I would say that the fields that I'm familiar with, I don't believe they can abstract from the role of the researcher. And I would probably go as far as to say that I don't really seriously believe any field can abstract from the role of the researcher. I don't think this is a negative or some sort of problem to be solved. I think this is a kind of inevitable fact of how our world is constituted. And so it is to be acknowledged and reflected upon in how we do research and how we apply research after we do it. So I want to go back to Karen Barat, who I talked about in my previous little presentation, because she gives what I think is a very illustrative example of why the researcher is something that we should always consider. So Barat tells us the story of an experiment that took place in 1922. It's called the Stern-Gerlach experiment. And please don't ask me for details about this experiment, because it is a demonstration of space quantization, which I have no idea what that is. But apparently this was an experiment run by these two researchers who wanted to prove that space quantization was a thing. And they had a complicated setup with like silver plates on which things were supposed to be appearing after they did the experiment. And they were looking at this silver plate and there was nothing happening there. And they were like, well, maybe this means that space quantization doesn't exist. But then one of the researchers, bent over the silver plate as he was smoking. This was in 1922, so people still smoked. He was smoking a cigar. And very importantly, this was a cheap cigar because he was some sort of postdoc, so he didn't have a lot of money. So he was smoking a cheap cigar that had sulfur in it. And because of the sulfur in the cigar, the reaction that had been on the silver plate but not visible to the eye then became visible to the eye. Again, don't ask me how this reaction works because I don't know. But so this is a story. And according to Barat, this shows that the researcher has an influence on the experiment, that they may not even be intentionally doing. It's something that importantly has to do with also cultural factors. It has to do with gender in this case. So her point is that the way that society constitutes itself and the way research is actually carried out are not independent of each other. And there's always a chance that the researcher will influence the research in ways that can be intentional, but it can also be unintentional and unconscious. So I think we see this, I mean, all over the place. And I think we already see it in a very obvious way when we think about, okay, where do we think causality might play a role? Where do we think causality might be interesting or important to look at? Where do we kind of ignore possible causality relationships? So what we find interesting and important as researchers, and that again then is influenced by who we are. So for example, a lot of issues that concern women get less research than when they concern men. In medicine, this is a very well-known thing. And then there's also things like blind spots. So the idea that data are raw material. There's been a lot of literature on how data are not really raw material, but is always already shaped. Our confidence in algorithms, when it has been shown that algorithms are also, for example, sometimes racist because of how programs have been trained. So I think these are all things that we need to take into account. Things like also the diversity of test persons in all kinds of research, medical research, but also psychological research, where it has now been shown that a lot of things are not reproducible because they were basically only testing things on male students of Ivy League universities. So all these things play a role. So I think the researcher is not outside of whatever the experiment is or whatever the system is that they're experimenting on. The researcher is part of that, and we should take that into account. And I don't think that means that there's no facts. I don't think that means there's no truths to be discovered, but I do think that it's something that we should take into account and be reflecting on constantly as we do our research.
Okay,
and that was it.
Yes, thank you. That was a very clear statement. Okay, so next on my screen I have Sonia. Sonia, would you like to tell us your view about the role of the researcher?
Yeah, so my view is that I agree part with what Esther says, but not totally. So let me explain. I think when we study causal relations or any given phenomena, we typically make an idealized system. We cut it off from the rest of reality and then not all physical forces are playing a role, etc. So we study a thing in isolation, and we are very well aware that we do that, and it's idealized. But even given that, the role of the researcher can be important, but it's not always going to be relevant. It is important. So the role of the researcher can be that you look at it as the person who learns and intervenes, but it can also be the modeler. But let's focus on the one who learns and intervenes. So then this means that there will be an epistemic effect, because learning means somebody gains knowledge, and that means epistemic, so there's an epistemic effect. Now, when is an epistemic effect important when we study causal relations? According to me, that is going to be when the causality involves the knowledge itself, or when the information refers that the causal relation is about refers directly to the information state of the one who intervenes. That's in one case. I can give some examples in a moment. And the other one is the situation that Esther referred to, when there is no way to have an epistemic effect without an ontic effect, as in the quantum world, where every time I try to intervene or do a measurement, there is a change of reality, and hence there is no way of studying the causal situation without any intervention will have an effect on what is happening there. But that is not necessarily the case in all situations, right? In the classical context, I can very well study a causal effect, do an intervention, and that intervention is not going to necessarily have an ontic effect as in the quantum world is happening. But even in the classical case, when the causality is about the researcher or the epistemic state or the information state where the researcher plays a role, then you're thinking about, for instance, sentences that can, so an example that comes from logic would be the study of sentences that change their truth value because you are trying to learn them. There might be sentences which truth value you can never learn. So for instance, a sentence would be, it is raining outside, but you don't know it. Suppose the sentence is true. Before I tell it to you, it is true. It is raining outside. You didn't look because you're looking at the screen. You don't know it. But after you take that information into account, and it is a true statement, so now you learn that it is indeed the case that it's raining outside, but it is not longer the case that you don't know it. So that second part of the sentence is something that you cannot learn as a true statement. So overall, I tell you true statement before, and by learning it, the truth value changes. Now, there are lots of examples where the truth value of sentences change by an announcement or by trying to come to know something. And those cases, of course, I can also study these in a causal context, in a causal network. And if I take these into account, then the role of the researcher or the one who intervenes, who tries to learn, is going to be crucial. You can't study it without taking these effects into account, right? But I can have lots of examples where I don't refer to the epistemic state, like it's raining and you don't know it. So the fact that you don't know it, that refers to the epistemic state of a researcher. There are lots of examples where I just look at atomic sentences, basic facts of the world and basic values. And most of the examples that we have seen for the study of causal relations or in causal networks, etc., they deal with ontic facts, basic values. It's hardly the case that we are studying these higher order phenomena and epistemic features. But those are very interesting. But I myself haven't yet worked on these situations where these, also I worked on quantum information, but not yet on the causality there. But I do think that is also very interesting, because there you also see the same thing happening. And what is very interesting in that case is also that, yeah, there are lots of questions that pop up, like the causal order of events might be entirely different in the quantum world from in the classical world. You get causal relations between space-time regions. Yeah, so a lot of things are opening up if you're looking at the quantum world. And but there the role of the researcher or the one who intervenes is going to play a role. So every epistemic effect will have an ontic effect. Yeah.
Okay, thank you, Sonia. We can move to Kees, please. Your 5 minutes.
Thank you. I think Esther and Sonia paved the way for me a little bit. I think if I have to make a statement, I would tend to agree more with Sonia than with Esther at the moment. In that the role of the researcher can sometimes be more relevant than in other cases. I was going to give you a kind of personal background on my views. I have a background in physics, and now I'm working in economics. And Sonia was mentioning already quantum physics, and in quantum physics, I don't know how familiar you are with quantum physics, maybe not all of you, but there's a very well-known phenomenon called the collapse of the wave function. And there's this famous example of Schrödinger's cat, and the cat is with a certain probability poisoned or not, and we only know whether it's poisoned when we open the box, but even more strongly, even if we don't open the box, the cat can be in some kind of superposition between these two states. So there the role of the observer is extreme, because the observing act itself is determining whether the cat is dead or alive. At least that's how it's brought in the popular literature. Actually, it turns out that consciousness in itself is not really relevant in this whole story. What is important is that the wave function is collapsing because something that is happening at the quantum level is magnified until the macroscopic level. And but this observer effect is still there in that sense. So let me see. It's a bit comparable to measuring the pressure of your car tire. You can only measure it by letting a little bit of air out, and if you do that, then you change the pressure already. So in quantum mechanics and in physics more generally, I think it's resolved by trying to make links between different observations. So you prepare a system like Sonia was suggesting, an idealized system, and then you look at subsequent measurements that you do, and then you try to find the relations between them. And then we have the Schrödinger equation that describes the evolution of the state of the system. You can ask questions like, does the wave function exist? But it doesn't make a lot of sense because you will never observe the wave function. The wave function is only there to describe the relations between the different physical events. So this idea of modeling the relations between different pairs of events, I want to apply to economics and to see where is this possible and where is this not, and when is the role of the experimenter important and when not. And I've been active in 3 fields of economics. One is, well, I think also Frank is familiar with that, is measuring. So we are talking about economic statistics, for example, measuring GDP. I don't think when you are measuring GDP that you will have a very big influence on the system. Maybe when you want to measure in more detail what's going on in the economy and you send out surveys, you influence the people who fill in the surveys just by taking up their time. But apart from that, you're not really influencing the system. So then there is empirical data analysis, econometrics. There it really depends on whether we are talking about high frequency, time series, financial data, because there we have plenty of data. And we can estimate models and try to infer from the models where the causalities are. In macroeconomics, you cannot, you don't have a lot of data and you cannot do experiments. So you have to rely on natural experiments. And so, for example, a tax regime change, and then from that you can estimate model parameters slightly better than without these regime changes. And finally, I was thinking about experimental economics. In experimental economics, we try to control the situation very carefully. And there, of course, Esther's argument comes in, because what is the design of the experiment is determined by the research question that we want to address, and also by the kind of responses that we expect from the participants in the experiment. And there, of course, there can be plenty of biases. So in that sense, we are actively involved in the whole process. I think I will leave it at that.
Okay, thank you very much to the 3 of you for trying to elaborate on what the role of the researcher is or can be or should be. We can have another quick round of Q&A directly to the panelists. Does anyone want to kick off with a question? Okay, René, I see your hand, please.
Yeah, I was just thinking that I'm not sure if all researchers, at least in my field, are aware of their involvement in this in exactly the same way as Case describes. And I think many of people in the medical field, because you could say, well, perhaps this is science philosophy or something, they're not very interested in this at all. But I think it is extremely important. That was just an observation that I wanted to make. But we are aware of, let's say, how we are playing a role in this.
Yeah, thank you. Anybody else wants to have a quick go on this? Esther, do you want to react?
I just wanted to ask a question of Kees and Sonia, because I'm intrigued by this idea of the idealized system. So how do you kind of come to that idealized system? And would you not think that there also you're making certain decisions that might be like influenced by like cultural structures, biases? And I see people nodding now. I feel very validated all of a sudden. But, so I mean, I get the idea that you would still be aware that's an idealized system, but how do you get from the system to this idealized system, and what kind of decisions do you have to take in that process?
Yeah, I think that's a very good question in a way, because so you open any physics book, that's the first thing they write, right? So we are aware gravity, everything plays a role, but we're not going to study that. And we are trying to put these parameters all out of the equation, and we only focus on this. If you take a logician who wants to then design a model for some phenomena, people talking to each other, exchanging information, okay, so then of course the intentions and the ideas and the beliefs and the biases all play a role. We know that, but we abstract away, right? We only are going to focus on what has been said, and we assume everybody is hearing everything that has been said, but that's a huge assumption. So yeah, I think all these things need to be made clear before you start. You have to be aware of it before you draw your model, and that makes it also extremely difficult to teach our students how to design a model from a given phenomena, because they need to be aware what level of abstraction to adopt, because you can of course put all these parameters back in. Makes it completely difficult, and a lot of people are trying to one by one add different things in. They see that things don't really work out the way they want. Maybe it can give a better prediction. Yeah, and there are different levels of abstraction as well that you can then zoom into. I think it's a very good question. We are trying. I don't think we have a perfect recipe for doing so. Yeah,
I think on the quantum mechanical scale, we are hampered by the fact that everything is uncertain at that scale. So it's very difficult to manipulate these systems. And at a much higher level of economic experiments, there we are hampered by the complexity of the interaction between the participants. So I think ideally you're somewhere in between. And so I can imagine that there things work optimally. And so I agree totally with Sonia that it's very important, and also with Esther, to address this question. Of course, in some cases, things are very clear, like we have this double slit experiment where it's very convincingly demonstrated that there is this wave nature to the quantum mechanical world. But of course, you can never rule out any interference with other systems. I remember that there was this fusion that was claimed to be invented by some researchers, and it was impossible to reproduce it. And it turned out that in the end, there was an electric cable running through the building, and by the induction of that cable, the measurement instruments indicated that they succeeded. So you always have to be very careful and always try to find sources of disturbance.
Thank you. Okay, I don't see any other hands for now, so let me try to systematize a bit what I've heard so far, because it seems to me that what is emerging from the three contributions now is that even if we want to agree that the researcher has a role, there is still quite a lot of work that we have to do to qualify this claim. On the one hand, we may have different actors or even different roles of the researchers involved. And this I take from the idea of Sonia of the modeler versus the learner versus the actor that intervenes. And then if you agree that there may be different roles, maybe the role and the possible interference may be more or less severe depending on who you are and where you are in this process. And this is where I also found interesting Sonia's idea of the epistemic effect versus the ontic effect in a sense, because you may distinguish the two and then claim a more or less relevance of the interference of the researcher depending on the one that you are actually interested into. So there is another point that I wanted to raise, however, and I'm saying this to play the advocate's devil and to make the discussion a bit alive, and a possible counter argument to the example of Esther, and reporting the experiment that Barad tells in her book, because some people may say, but look, the person with the cigar in that experiment, that is not about the role of the researcher. This is the serendipity of how we make discoveries in science. So that how it could be kind of counter-argued, and I don't know how we have to react to that. I think there is quite a lot that we have to spell out to say that even if it is true, then we may want to go back to square one and kind of say exactly what these roles are and how relevant they are possibly to studying the phenomenon. So I don't know, I'm just putting on the table some more ideas and some more questions. Yeah, Esther.
I mean, I think, yes, in a way it can be seen as a kind of random thing, like the cable that Kate was talking about. But in this case, it is the researcher, and the fact that this person was smoking a cigar and was smoking a cigar of a specific, with specific ingredients, was due to the researcher's gender, to their economic position in the society. So I think it is in a way something that accidentally happened, but it shows that the researcher does have some sort of, and all of the baggage and all of the kind of cultural determinations that make a researcher of a certain kind matters. I mean, I think it does matter that research for a very long time was predominantly done by men, and that kept certain things out of the field of vision because particular elements may just not have seemed very interesting. The same with the fact that a lot of researchers up to now actually have been white in a lot of fields. And this has repercussions, I think. And that's not even going into the fact that maybe there are indigenous cultures that would research completely different questions from the ones that we find interesting, because they have a completely different worldview. So I feel, I'm not saying that this has to be something that every experiment gets totally obsessed with and spends like inordinate amounts of time thinking about, but I do feel that it's something to have in the back of our minds, and that is really something that we should teach in all disciplines. And I think this is why I was, when Renee said that in medicine a lot of people don't even ask these questions. That's the most worrying, I feel. It's not about how you answer the question. It's more, if this question is not even getting asked, then I really feel there's something that is being left out of consideration.
Yeah, thank you, Esther. I guess the reason why I was trying to play the advocate's devil on this occasion, let me pin again Case so that he's back in his role for the next 2 minutes, is the following. For those factors that now we know that play a role, as you say, gender, ethnicity, the perspective and things like that, then we can work towards having more awareness. And this, in a sense, is again a point that was mentioned earlier, that not everyone has sufficient awareness of the role you have as a researcher. Okay, but what about the role, the factors that we don't know may play a role? Exactly. So that's why I wanted to play a bit with the idea that, oh, that was just serendipity, because we couldn't possibly know that if you smoke this cigar close to this technical apparatus, then the experiment will work. Okay. So that is kind of the difference that I wanted to try and pick with the counter objection, in a sense. But I think I side more with you than with those claiming the independence somehow, just to disclose the the intention. Okay, so